Welcome to Ask and Learn.
Problem 24.30. We have this little smiley face of charge here. The full circle out here has a charge of -3 microcoulombs and has a radius of 6 centimeters. This little short arc that subtends 90 degrees has a charge of 2 microcoulombs and has a radius of 4 centimeters. And then this dipole that's perpendicular to a radius of this circle has a dipole moment of 1.28 times 10 to the -21st coulomb meters. And so if we call this point P, it's at the center of the two circles, we want to know what the voltage there is, with our usual assumption that at infinity, the voltage is equal to 0. So the dipole moment here is perpendicular to this, so there's not actually going to be any potential from it. We can see that from the expression for the potential from a dipole, P cosine theta. And of course, we're not given a distance from here, so that's kind of a bit of a clue as to the fact that this isn't going to contribute anything. The P cosine theta divided by 4 pi epsilon naught r squared. Theta is 90 degrees, so this goes to 0. And so the potential from the dipole is 0. Now each of these circular arcs has some given net charge, and since each point on the arc is the same distance away from our point P, this actually ends up just acting like a point charge a distance r away from P. So then our remaining potential from the short arc, we've got, let's call it Q2 over 4 pi epsilon naught R2, and then Q1 over 4 pi epsilon naught R1, so now Q2 is 2 microcoulombs, and its distance is 4 centimeters. This has a charge of -3 microcoulombs and is a distance of 6 centimeters away. And now we note that both of these evaluate to 1/2 microcoulomb per centimeter, and so this also cancels. And so the net potential at this point is 0.